Java to replace the pseudo-random number generator used by all the methods in the class, one can simply subclass random and supply a new implementation of the core generator random. Starting with CPython 2.3, the method random uses a Mersenne twister pseudo-random number generator. This is a fairly new technique that has been shown to result in generators with impressive periods and otherwise good sequences of pseudo-random numbers. More concretely, for the set of parameters used in the variant implementation known as MT19937, the generator has an enormous period of 219,937 minus 1. The approach and the MT19937 variant were introduced in the following paper by Makoko Matsumoto and Tajiki Nishimura. Matsumoto and Nishimura also made the C-code implementation of MT19937 available under a fairly liberal open source license, with a few mirror changes in order to integrate the code into CPython. It is the 2002-126 release of this MT19937 implementation that acts as the underlying generator for the random method. The original unmodified code is available for download from the official Mersenne twister homepage. Let's now look at Ruby. Pseudo-random numbers can be generated in Ruby by the kernel method rand. This routine takes one argument dubbed max. If the magnitude of max is greater than or equal to 1, then rand returns an integer uniformly distributed in the range 0 to max. In this context, like Perl's int routine, the method to I returns just the integer portion of the real value number without any rounding, and the method abs simply takes the absolute value of the resulting integer. However, if the magnitude of max is less than 1 but not 0, rand returns a real valued number uniformly distributed in the range of 0 to max. If max is 0, the default value, if no parameter is explicitly supplied, rand returns a real valued number in the range of 0 to 1. Like Python, Ruby uses a Mersenne twister pseudo-random number generator. In fact, it also uses the MT19937 C code released by Matsumoto and Nishimura. However, Ruby uses a variant release on 2002-10 that is potentially faster on some platforms, but it has been reported to be slower on Pentium 4 systems. On the Mersenne twister homepage, this release is listed as version considering Shon Koku's code and dated 2002-11. Pseudo-random real-valued numbers can be generated in Octave using the functions rand and randn. Additionally, a raw vector with a random permutation of integers can be generated using randperm. If the routines rand and randn are called without any arguments, they both produce a single random value. However, if they are called with a single numeric argument n, they will generate a square n by n matrix of random values. If they are called with two arguments, say n and m, rand n generates values that have a Gaussian distributed with the mean 0 and standard deviation 1, while rand generates values uniformly distributed in the range 0 to 1. Note that the latter differs from the other similar routines previously presented that generates values in the range 0 to 1. The values written by rand and randn are generated using routines from randlib, a library of C and Fortran routines for generating pseudo-random numbers. The package is maintained by Barry Brown of the Department of Biostatistics and Applied Mathematics at the University of Texas, MD Anderson Cancer Center, and can be downloaded from the department's software repository. The package generates random numbers by combining the output of two multiplicative linear congruential generators. Doing so results in an aggregate generator that has a period of 2.3 times 1018. The implementation of this generator is based on a Fortran 77 port of the Pascal source code. Let's now look at the bash shell. Pseudo-random integer values can be obtained in bash by retrieving values from the special shell variable random. Each time a value is read from this variable, bash generates a random integer, uniformly distributed in the range 0 to 32,767. If a value is assigned to random, the value is used as a new random seed for the generator. The variable random can also be used to generate integer values in C shell and corn shell. However, it isn't supported by the original Bourne shell. Retrieving values from random in bash invokes the following linear congruential pseudo-random number generators. Here, R seed is an unsigned long that is initialized to 1, but then later set to the sum of the current process ID and the shell start time. If you recall, this is the exact same generator given in the ANSI ISO C standard as the example implementation of the rand function. The code snippets only differ in the manner that they remove the 16 low order bits from the state variable and then ensure that the resulting integer is in the range 0 to 32,767 across all platforms. Specifically in bash, this is done using universally fast bit manipulation operators, while in the standard C example code, this is done using division and modulus operations. However, it is interesting to note that the GNU C compiler and presumably other modern C compilers actually compile both variants of these two operations to the same pair of processor instructions. So that's all for random number generators. Hope it's been informative. Thank you for listening.